Auga! Auga! Sorry. All right, welcome to video lesson 8-5, our lesson on the counting principle. Here we go. Okay, as we look at this problem right here, how many ways can marbles be drawn from the two buckets? If one marble is drawn from the first cup, and two marbles are drawn from the second cup without replacement. So all we want to know is we want to know how many different outcomes there are possible in this scenario. I'm going to have three events. So let me get my marker on here. One, I'm going to multiply the number of outcomes in the first event times the number of possible outcomes in the second event times the number of possible outcomes in the third event. As I look here, my first bucket has three marbles in it, so I can choose up to three different marbles. When I draw a marble out of the second bucket, I'm going to have three possibilities on the first draw, and then let's say, for example, I drew the red one out, so he's gone. There are two marbles left to choose from in the third choice. So 3 times 3 times 2 is 18. There are 18 different ways that I can draw one marble from the first bucket and two marbles from the second bucket without replacement. Okay, here are some formulas. You probably don't need to memorize them yet, but have them written down into your notes, or I think they are. A linear permutation, we already know. We've gone over that. P of n is n factorial. A circular permutation, so there is no beginning point and ending point, so the first one doesn't matter, but after that, it's going to be n minus 1 factorial. We know that permutations, we already know this formula, it's n factorial over n minus r factorial. Distinguishable permutations, and I will explain this, but it's n factorial over n1 factorial, n2 factorial, etc. And the combinations we've already gone over. It's n factorial over n minus r factorial, r factorial. Okay, so we're going to try these right now. How many, using the letters in the word math, that's 4 letters, M-A-T-H, how many different arrangements can be made? So how many permutations? So this is just going to be 4 factorial, which equals 4 times 3 times 2 times 1, which of course now equals 4 times 3 is 12, 12 times 2 is 24. How many arrangements in a circle? So we have 4 people. We want to sit them at a round table. So the order doesn't matter, or the first person doesn't matter. So it's going to be 4 minus 1 factorial, or 3 factorial, using the formulas we just wrote down, which is now equal to 3 times 2 times 1, which equals 6. Okay, how many arrangements of 3? What this means is 4p3, which we know from our shortcut now is 4 times 3 times 2. We'll stop right there, which is 24. If you still want to use the formula, it's going to be 4 factorial over 4 minus 3 factorial, which is 1 factorial, still equals 4 factorial over 1 factorial. 1 factorial is 1, which is still 24. Okay? If we look at how many arrangements of 2, what that is asking us to do is 4p2, which according to our shortcut now is 4 times 3, which equals 12. Of course, it's also, if you want to, you can use the formula. You know, I'm not big on it. 4 factorial over 2 factorial, which then becomes 4 times 3 times 2 times 1 divided by 2 times 1. The 2's and the 1 cancel, and I still get 12. And how many groups of 3, what we're saying on that one now, let me go back to red, or let me go back to blue, is going to be 4c3, which according to my shortcut, which we know, is 4 times 3 times 2 divided by 3 times 2 times 1. Switch colors, the 3 and the 2's cancel, and I get 4. If you don't want to use my shortcut, you can do it the old-fashioned way. You're going to do 4 factorial over 4 minus 3 factorial, which is 1 factorial, times 3 factorial. And doing that, you're still going to get 4. Okay, in this problem right here, a college student is preparing for a course schedule for the next semester. They're choosing their classes. The student must select one of 2 math courses, one of 3 science courses, and one of 5 social science courses. So therefore, they're going to choose 3 classes. So I'm going to multiply 3 numbers. In my first choice, it's the math courses. They only have 2 choices. Geez, too bad for them. Missing out on some fun math courses. They have 2 math courses to choose from. Then they have 3 science courses to choose from. And they have 5 social science courses to choose from. 2 times 3 times 5 is equal to 30. There are 30 possible schedules for this student. Okay, I have one more problem here in physiology. In a physiology class, a student must dissect 3 different specimens. So once again, I'm going to have 3 events, or 3 choices. The number of choices I have for the first one is 9 earthworms, 9. I can choose one of 4 frogs, that's 4 frogs. Or I can choose one of 7 fetal pigs. Okay, so 9 times 4 times 7, actually I'm whipping out my calc because I'm lazy. 9 times 4 times 7 is 252. 252 different possible combinations of dissections for this student. Here's the last problem. In Pennsylvania, each standard automobile license plate consists of 3 letters followed by a 4-digit number. How many distinct Pennsylvania license plate numbers can be formed? Let me get you started here. There are actually 7 choices. Just ran out of room. 1, 2, 3, 4, 5, 6, 7. There are 7 choices. The first 3 are letters. The second 3 are digits. First 5 people to email me with the correct number of license plate combinations, next possible combinations, gets a bonus point on our next test or quiz. That's all she wrote, folks. We shall see you soon.